this was a good one related to the topic. And you just copy the link and put it into the button.
Seven photos.
That I think that's basically the photos from the stuff. I just use the same photos
Minimum
from
of
the
two
stuff and
different
use it to-
layouts. Written text.
I know, it's like they don't think it's everything. Hello.
Hi. Sorry we're late.
Oh, good.
There's a test in here before and we just had to wait for them to finish. Today is not the hardest of classes, but it's one you have to kind of get the concept of in order to understand. What we're gonna do is we're gonna look at how to find the relationship between cost, profit, and volume.
Is the online class on?
The online is on, yeah. And we are recording, so we're good. And they can see me, so it's all good.
It usually says screen sharing.
I'm see it, I'm sure we're on screen.
I can see and hear it perfectly.
Oh, and you. Huh? There we go. Oh, shines. Online, can you see the presentation? Can somebody give thumbs up or something?
Yes, I
What's that?
can see.
Okay, perfect. They can see it, so we'll start. Okay, we're gonna start. We're a little bit late today. Sorry about this, but there was a test in here before. We're gonna talk about the relationship between profit, cost, and volume today. So that we can do what if analysis. So if we need to find out the profit with this production, how much is the profit? Or if we're looking for this profit, how much do we have to produce? We have our land acknowledgement, of course. We are sitting on land in the Turtle Island. We are stewarding it until we return it. And we will return it in a better condition than we found it. I doubt that one, but we're gonna give it a whirl. Talk about classifying costs in terms of variable costs, fixed costs. Then we're gonna introduce a concept called mixed costs. And it's not as weird as it sounds. It actually kind of makes sense. Then we're gonna separate things into their costs, and then we're gonna calculate contribution margin and figure out what that means. Now, only because some people, I've always said to all my HR people, be careful how you incent people. Because people will always do what you incent them to do. When managers, old school managers during period of the pandemic and now when we have more people working offsite than onsite, old school managers can't handle it. They don't understand it. If I can't see you, you're cheating somehow. So what they did is they put all these cheap safe codes in. They track your key functions, see what you're typing. They track how often you move your mouse, because if you're not moving your mouse, you must be doing something else, right? So you incent people this way and then people get creative and cheat. This is for sale for $25. To answer that, what it is it sits on your desk and you put your mouse beside it and it randomly moves your mouse around for you. Stupid little invention. Why would anybody do that? Because now you can walk away from your computer and Big Brother doesn't know. So be careful how you incent people because people will find a way around it every time. And I'm gonna let somebody else speak for a few minutes.
Hello and welcome to this session in which we would look at cost, volume, profit analysis, for short known as CVP. What is cost, volume, profit analysis? Simply put, it's a tool. It's a tool to do what? It's a tool to help managers make business decisions. Now, how do we use this tool? Well, you have to understand what is cost, volume, profit analysis. The best way to understand it is to break down the components of this formula, cost, volume, profit, and see what each one means and see how it's all put together. Starting with the cost. What is cost? What do we know about cost? Well, we have two types of cost. We need to understand that we have variable cost, cost that varies with the production, with the selling of each additional unit will incur this cost. So it varies with sales, it varies with production. An example of it, if you're manufacturing a car, every car needs 4 tires. So every car you produce, you need at least 4 tires, So it varies. The tires are a variable cost in terms of car production. Fixed cost is a cost that does not change with production. So if we're discussing the car manufacturer, Ford Motor Company, well, in one manufacturing plant, they might produce 100 cars or 500 cars. It does not matter. The depreciation of the equipment does not really matter because it's a fixed cost. And they are renting a warehouse to produce those cars. The rental cost does not change. It's a fixed cost. So it doesn't vary with the production. And the assumption here is, variable cost and fixed cost. In this session, sometime I would refer to them as variable expenses and fixed expenses. It doesn't matter whether I used cost or expense, it's the same thing. So this is what cost is. Volume, what is a volume? Volume deals with quantity of units sold or produced. Okay, so we need to understand what is a quantity. Well, the quantity is if you sold 100 unit, well, that's the quantity of the unit, 100 unit. And if you produce 100 unit, that's the quantity, 100 unit. So there's a relationship between cost, volume, and profit. And what we're saying here, volume do matter, especially when we are dealing with variable costs. Remember, variable cost varies with the number of units produced or the number of units sold. So that's why quantity is important. The third component is profit. What is profit? Now let's think about profit. How do we make a profit? Well, let's think about it for a moment. We sell something, we have sales. Then we have to deduct from the sales the cost. Well, remember, what is cost? Cost, we have variable cost or variable expense and fixed cost. Once we take the sale, deduct our cost, we should come up with our profit or net operating profit. Simply put, we're going to take sales. And what is sales? Now let's break down sales. How do you know what sales is? Sales is the selling price. Whatever you're selling that unit price is, times the quantity sold. How many units you sold times the price gives you sales. From the sales, you are going to deduct your variable cost. What is variable cost? It's your variable cost per unit times how many quantity you sold. So Q is the same. So if you sold 10 units, well, you sold 10 units, the variable cost of 10 units will need to be expensed or cost. Then after we deduct variable cost, we deduct fixed cost, and we come up with our profit. And this is what I showed you right here. Sales minus variable cost minus fixed cost equal to your profit. Now, here's what you need to know. The term you need to know. Selling price minus variable cost equal to something called contribution margin. So selling price, so if you're selling something for $10, it has a variable cost of 4, we would say 10 minus 4 equal to 6. We say the 6 is the contribution margin per unit. Now, if you're selling 100 units, you multiply this by 100, you multiply this by 100, and the contribution margin will change. But nevertheless, it's the same concept. That's the contribution margin. So 6 is the contribution margin per unit. Now, from the 6, you deduct your fixed cost. Let's assume fixed cost is 2. Yield profit is $4. Now we can simplify this formula a little bit further. Why? Because if you notice from a mathematical perspective, if this sales minus variable cost equal to the contribution margin and Q is an element common to both, we can say that, and by the way, before we simplify, this is the contribution margin income statement. So we did this in a prior session. So hopefully you are familiar with this formula. Nevertheless, I just explained it. So here's what I do. I can simplify this formula and I can say profit equal to, if this is the contribution margin, So it's the contribution margin times the quantity minus fixed cost. So this is the same as this, just simplify. Now, what I want you to do is to jot this formula down. I'm going to show you how to solve problems with this formula later on. Later on means in few minutes when I work a problem. So we need to look at an actual problem for this to make sense. Now, if you're watching, you must be either an accounting student or a CPA candidate. I'm glad you found me. If that's what you're looking for some help in CBP, go to my website, farhatlectures.com. I offer additional resources. I can help you. The reason you're watching is because you're looking. So to illustrate the concept is to actually work an example. So we're going to be looking at Adam Electronics retailer. Adam sells tablets. That's what he does. And this is the contribution margin income statement for the month of December. Adam sells for that month 500 units, 500 tablets, and the selling price per unit is $500, the same. Well, what does sales equal to? Well, quantity times selling price will give us 250,000. Now, Adam will need to account for variable cost. Well, variable cost is $300 per unit. We sold 300 times the quantity is 500, same as quantity above. The variable cost or the variable expense, notice if I said cost or expense, they mean the same thing. Your textbook or your CPA review course might use either expense or cost, so it's the same thing. Now, when we take sales minus variable cost, remember, selling price minus contribution margin, sales, whether it's times quantity or not, it doesn't really make a difference, okay? That's gonna give us contribution margin. So this is the total contribution margin for this company for the month of December, and this is the contribution margin per 1 unit. So each unit that Adam sells, he'll have a contribution margin of $200. Now, from the contribution margin, the company will deduct their fixed expenses. What are fixed expenses? Rent expense, tax expense, insurance, utilities, so on and so forth. So they will deduct their fixed expenses, and from their fixed expenses, we come up with net operating income. Again, this is the contribution margin income statement that you need to be familiar with. But here we need to focus a little bit more on the concept of contribution margin, because that's very important. Contribution margin is needed for Adam. Why is the contribution margin is needed? To cover his fixed expenses. Otherwise, he would not have any profit. So Adam will need to have at least 80,000 of contribution margin. Otherwise, he will not have a profit. Why 80,000? Because the fixed expenses are 80,000. Give me 80,000 or I'm gonna be not profitable. Okay, so the contribution margin per unit is $200. So it's very important to understand what does this 200 means. So I'm gonna have to explain it to you. Think about a bucket. So we have a bucket. So I'm just gonna draw a bucket. I'm not really good at drawing, but you guys will get the point. So this is a bucket. And this bucket is called fixed cost bucket, fixed cost or fixed expenses. And this bucket is $80,000, needs $80,000. What does that mean? It means before Adam makes a profit, and this is the profit bucket. This is the profit bucket. This is the profit. Before Adam starts to make a profit, simply put, let's assume there's basically, once this is filled, it will go to the profit. So what does that mean? It means for every unit we sell, we put here $200, $200, $200, $200. We keep on, this $200 will keep on going toward the fixed cost until the fixed cost bucket is full. Once the fixed cost bucket is full, if we add 200, it's going to go to the profit bucket because the fixed cost has been filled. So that's why it's very important to understand the role of the contribution margin per unit. Now we can now compute how many $200 do we need to fill out the bucket. How many do we need to fill out the bucket to complete our fixed cost? Well, simply put, if we know our fixed cost is 80,000, 80,000 divided by $200, which is the contribution margin per unit, what does that mean? It tells us we need 400 tablets. Once we sell 400 tablets, if this is empty, once we sell, so 200 times 400, oops, let me go back to and draw the bucket, okay? So once we sell 400 tablets, the bucket of fixed cost is filled, and every additional unit we sell, it's going to put the 200 in the profit bucket. So this is the importance of it. So let me show you exactly what does it look like from a contribution margin income statement, assuming we sell 400 units. If we sell 400 units, 400 units times 500, our sales is 200,000, variable expenses 300 per unit times 400 unit, 120,000. Our contribution margin is 80. And voila, fixed expense is 80. We don't make any profit. So at this point, what happened is this, that fixed cost bucket is filled. We fill out that fixed cost bucket. So if we sold 400 units, I showed you, we'll fill it. So this is called also the break-even point, which is profit equal to zero. And when does the profit equal to zero? We'll talk about the break-even in a separate recording, is when the contribution margin equal to the fixed cost. The total contribution margin, not only the contribution margin, because the contribution margin per unit is only $200. Now, what happened if we sell one tablet above 400? Now we know if we sell one tablet above 400, for each tablet we make a profit of $200, because well, once the 200 gets here, it doesn't fit in this bucket anymore, so it's going to go to the profit bucket. So the 200 will go here, and this is what we mean by for each additional unit. Now, if we want to know how much profit would Adam make if he sells 440,000 tablets, it's easy. We'll take 40 units. Why 40? Because 400 is for the fixed cost. The additional 40 is the profit. So the 40 times 200 per unit will give us 8,000. No need for the contribution margin income statement. However, I'm going to use the formula that I showed you earlier that we computed. We said profit equal to the contribution margin times quantity minus fixed cost. Well, the contribution margin per unit is 200. I switch them. The quantity is 480. 8,000 will give us 88,000 minus 80,000 will give us a profit of 8,000. So notice how basically we could go back, and I told you to copy that formula down. Now, bear in mind, we make certain simplifying assumptions when we are performing those CVP, cost volume profit analysis. I need to explain them to you because you might see them in a multiple choice question. So it's very important to be familiar with them. One is this: selling price does not change with volume. And this is not really true in the real world. What does that mean? So those are simplifying assumptions so we can understand this process. What does that mean? Sometimes when you sell more, if you have a demand for your product, you might increase the price. Here we're assuming the price does not change. The opposite is true. If you don't have enough demand, you might lower the price. We don't assume this. We assume that all costs are strictly either variable and fixed. And that's not also true in the real world. And we talked about this when we talked about how costs behave, variable versus fixed. For our purposes, we keep it simple. It's either variable, 100% variable, or 100% fixed. And we assume later on, when we do multi-product company sales, when we have more than one product selling, we assume the sales mix is constant. So if we have 2-3 product A and product B, we assume we're selling, for example, 30% of product A and 70% of product B for the sales mix. And that's not really true also in the real world. But in the real world, the software, Excel sheet, algorithm will make adjustments. At the end of this recording, I'm going to remind you, if you are watching, you must be again looking for some help in your accounting courses or.
All right. So he's covered everything that we're going to cover in terms of what contribution margin means and whatnot. He's done it one way. I'm going to do it a different way. You're going to come up with the same answer. And I hope one of these makes sense to you. So one of them may or may not make sense, but both of them probably won't. So we have to understand costs. I've hammered this. We can't change the price. It's a homogeneous product. Everybody else is making the same thing. I can't charge $30 more for it to make $30 more profit. So the only way I can become more profitable is to understand my costs and to hammer them down. So let's assume everybody loves pizza, right? We're having a pizza. Anybody here lactose intolerant? Because pizzas suck if you're lactose intolerant, I gotta tell you. They really are. A pizza without cheese is not good. But if you're running a pizza shop, there's a couple things you need to know. How much do we make for each pizza? What's it cost us to make a pizza? If I have fewer hours, am I going to sell less pizzas? Stuff like that. Are there factors that are going to affect my profit? This is what we're going to look at today. If we're running a pizza shop, what do we have to understand about our pizzas? I talked about costs earlier, and the one thing I'm going to say about what he just said is, he said they're either 100% fixed or 100% variable. They're not. They start that way, and then they change them. So we actually have variable costs, we have fixed costs, and we have something called mixed costs. And mixed costs, when I get there, you're going to see that it makes sense. Once you understand the relationship between the three legs of the triangle, Then you can make prudent decisions about how you allocate stuff. But you have to understand it first. Remember our management decision tree that became massive and bad and we hated? We make a decision. On the best possible information we have, we make a decision. Put it in the real world. The real world plays around with it and throws you back results. The results may not be what you expected to get. It's called variance. So we look at the variance from what we expected to get and ask why. What happened? Were the changes in the environment? Something's wrong. But every time we do it, we try to get better and better and better at making decisions by putting more and more feedback in it. Revenue. Revenue is a factor of what we sell, how many, versus how much we charge for it, what the cost is. Q times price is revenue. The more we sell at the same price, the more revenue we make. Our assumption is it's linear. There's no economies of scale. So if we sell one pizza, we sell it for $10. If we sell 100 pizzas, we sell it for $1,000. 1,000 pizzas, $10,000. It's $10 a pizza for as many as we want to do. So it's a linear line. It's a straight line. Cost is going to be the same way for variable cost. Number of pizzas times variable cost is going to be our total variable cost. We're also assuming it to be a straight line. We're assuming there's no economies of scale here either. So it's $3 in variable cost to make a pizza. It's also linear. $3 for one pizza, $3,000 for 1,000 pizzas, $30,000 for 10,000, etc. Right? So now we have two straight lines that we have to deal with. Fixed costs are interesting because it doesn't matter what we produce. If we produce one pizza, we pay rent. If we produce 5,000 pizzas, we pay rent. It doesn't change based on how many pizzas we make, as long as we stay inside. What do I mean by that? We're going to get to a point where in this room, we can make a certain number of pizzas. If we try to make more pizzas than that, we got to blow that wall out and go to the next room because we need a bigger room. That is, it's called a relevant range. We'll come back to that in a second. But as long as we're within the relevant range and say we can make 5,000 pizzas in this room, from one pizza to 5,000 pizzas is the relevant range, our rent is not going to change. If we try to go above the relative range and make 5,010 pizzas, we can't because it doesn't fit in the room. So anything over 5,000 pizzas pops us through that wall and we have to get another room. Then we go from rent being 4,200 to rent being 8,400, and you change that. But for the time being, we're going to assume $1, 4,200, one pizza is 4,200, 1,000 pizzas, 4,200, 5,000 pizzas, 4,200, it doesn't matter. So we have a flat line for our rent. So said, as long as we're inside the relevant range, it'll be fixed as long as that. If we go outside the relevant range, we may have to change. So we can produce, and it makes sense. I can produce 5,000 pizzas in this room. If I want to produce 6,000 pizzas, it's 1,000 pizzas more than I can do here. I'm going to need a bigger room, right? So that's all it's saying. So if we go up to 6,000 pizzas, we need two rooms. That's 8,400. And it looks like a step. It's called a step fixed cost because of that. It's fixed till it's not, then it's fixed again till it's not, then it's fixed again until it's not, and it'll keep stepping up that. Variable costs do the same thing. Now, some variable cost is just strictly keyed to quantity. If I'm making pizzas, the biggest variable cost I have is probably going to be whatever I put on the pizza, plus what I make it with. So I've got eggs, and I've got flour, and I've got cheese, and I've got pepperoni, and whatever else you put on a pizza. And if you put the same amount on every pizza, every time you make another pizza, you make that much more of the sauces. Direct labor is also theoretically a variable cost, but it's a step variable cost because one person can make 4 pizzas an hour. I actually have no idea how many pizzas she can make in an hour, so I'm just going to assume it's 4. So as long as you're making 4 pizzas an hour, you can get by with one person making pizzas at $12 an hour. So it's $3 a pizza. You make 5 pizzas an hour, you need 2 people. Now your cost isn't $12 an hour, now your cost is $24. Even if you're making 5 pizzas. So you end up with steps of your variable cost. From 1 till 4, it's $12. From 5 till 8, it's whatever, $24 and $36, etc. What this means is that you can schedule people depending on what you expect your requirements to be. From midnight till 3, which I'm assuming is not a heavy time for pizzas, you can have 1 person. If you get the evening rush and whatever, you can need more people. So the exercise is, if we have a bunch of costs, what do we think is fixed? What do we think is variable? So monthly rent on a factory building, it's gonna be fixed, right? Accountant salaries, they're fixed because they're salaries. Medications, and I'm assuming we're talking about patients here, not my medications. My medications are pretty much fixed, but the more patients you have, the more medications you have, so they're variable. If we were running an HMO in the US where you get paid for bringing in patients and stuff like that, then your sales commissions for bringing in patients, which to me is just kind of weird, whatever, is variable. And the insurance, it doesn't matter, it's fixed. Now we end up with something called mixed costs. Mixed costs give people a headache. But if you think about it intellectually and philosophically, it's not that difficult. Let's assume that we're running our pizza shop. Come in the morning. There's no lights on. Turn the lights on. And we start running power at a certain price, right? However much power we use during the day probably doesn't change that much. Because we're running lights, we're running computers, and that's just not going to change that much. But the second we turn on our pizza ovens, we really start to consume power. So we have 2 different types of power costs that we're paying. The fixed cost, which is the lights, and the variable cost, which is the ovens. So it's a mixed cost. It's going to change depending on how much we use it. The more pizzas we cook, the more oven we use, the more power we use. So we have the fixed element, which is I just turn the lights on, that's not going to change. And then when we turn the ovens on, we really start to generate a cost. So that's the definition of a mixed cost. Any questions about the types of costs? Okay. We're going to try to find out ways to separate and identify these mixed costs. There's 4 real ways to do it, and we're going to concentrate on 2 of them. Well, we're really going to concentrate on 1. The first one is the account analysis. What this is, it's a bunch of people that have done the same thing forever. They understand the process really well. They can look at a cost and go, yeah, I know where that belongs. That's not a problem. It's generally speaking for small costs that don't matter. And it's not going to sway anything depending on how you allocate the cost. So that's the first one. It's very clear. It's for small cases. In a small company, that's probably the way it's done. The next method is a graphical method, which we're going to look at. It says, if we know what our revenue is and we know what our costs are, where do those lines cross to show us what break even is? It's not really exceptionally accurate method, but it's an easy method that you can show a picture of it and somebody looks at it and goes, aha, I see break even. I see the light at the end of the tunnel. So we're going to have a look at that. Then we have the high-low method, which says within our relevant range, we have a bunch of data points. What's the high series of data points and what's the low series of data points? And what's the difference between them? Because within our relevant range, that difference will tell us what our variable cost is. And then we have least squared regression. Has anybody taken statistics? Statistics. So you know what least squared regression is. It doesn't matter, we're not going to do it because it doesn't help teaching accounting. What it does is it says if we plot a line, and we have a bunch of points. We're going to get the line that takes the difference between points and the line and looks at the square of the differences, then tries to find, so it's complicated. It's hard to do. If you have a lot of computing power and you have a lot of different data sets, you would do it. Because gives you the best answer. Problem is, we know there's a little bit of leeway in here. We know it's not gonna give us the best answer, but it's the hardest thing to do, so there's no. For our purposes, it doesn't help me teach accounting, so we're gonna ignore it. So we're gonna look first at the high-low method. We have data sets. Specifically, we have production of volume and electricity costs. And we know that as we increase our volume, our electricity costs are gonna increase as well. But how much? So what we end up doing is we say, in our data sets, what's the highest level of production and the lowest level of production? And at that highest level, lowest level of production, what's our electricity costs? So we end up with April being our highest, where we produced 4,000 pizzas and spent $1,800 on electricity. And March is our lowest at 2,000 and spent $1,200 on electricity. So what? So the difference between the two, 4,000 minus 2,000, the difference is 2,000 units. 1,800 minus 1,200 is $600. So we have $600 that's accounted for by 2,000 units. Or 600 divided by 2,000 is 30 cents a pizza. So we know that our variable cost within that relevant range is 30 cents a pizza per pound. Say that again. The difference between the big one, the biggest, and the smallest is 2,000 pizzas. The difference in that electricity bill is $600. So we have $600 we have to allocate across 2,000 pizzas, and it comes out to 30 cents a pizza. Fine. So again, so what? So if we know at 4,000 pizzas, our cost is $1,800. We know that. We also know that the variable portion of that is going to be 30 cents times 4,000 pizzas, which is $1,200. So $1,800 minus $1,200 is $600. We've just figured out what the fixed cost portion of that bill is. So before we turn on the pizza ovens, when we walk in, flick the lights and the computers on, we're going to burn $600 a month in power. And then we're going to burn an extra 30 cents for every pizza we make. That's conceptually how we look at this now. There is a flaw. Flaw is we're taking a sample set that's not the entire global scheme. So we know that we're taking a piece out of the middle. And anytime you take a piece out of the sample set, it's just if this is our sample set, we're taking this piece here. We know that we're injecting bias into it because we're ignoring everything that's not on that line. So what we're saying here is we know it's skewed, but it doesn't matter as long as we're inside our range. If we go outside our range, it matters, but inside our range, it doesn't matter. Now, if we use the same result and took that, plugged it into a spreadsheet and ran multiple regression analysis on it using least squares, we would end up with something that looks like this. It's not the same. This is the exact right answer, but it's not the same because it is the right answer assuming 0 to infinity pieces. We don't care because we're looking at 2,000 to 4,000 pieces. So we're looking at a very small sample set inside this infinity, so we know we're skewed off. So rather than make you upset, crazy and whatnot, we're going to say that doesn't exist, ignore it. Are we okay with the high-low method so far? Are we okay with ignoring regression? You should all nod at that because regression is painful. You don't want to have to do it. All right. So now we know that we have variable costs, we have fixed costs, we have mixed costs. We know how to break down the mixed costs in terms of what's the fixed proportion, what's the variable portion. So now we can say, fine, if we are looking at our profit, we have our various ways of calculating profit here. What matters in terms of what we're going to look at? So just to make sure we're all on the same page, we have our first 6 months of manufacturing costs here. If we're going to use the high-low method, what 2 months are we looking at? What's the high month? August. 7,500 units and 46,500 costs. The low month is May. We have 3,000 units and $24,000 costs. What's the difference? 46,500 minus 24,000 is, I don't know what that is. 22,500. 7,500 units minus 3,000 units is 4,500 units. 22,500 minus divided by 4,500 is going to be $5 a unit. So our variable cost is $5 a unit. So what? What's our fixed cost? Well, we'll pick, which one are we gonna pick? 3,000, doesn't matter which we pick, but we're gonna pick 3,000. Is that what we're picking? Yeah. So we have $24,000 worth of costs. We have 5 times 3,000 units, which is 15,000. 24,000 minus 15,000 is 9,000. So we know our fixed costs are $9,000. And then everything we produce after that's $5 a unit. It works the other way too. We took the low one at 3,000. If you take the high one at 7,500 and 46,500, it also comes out to 9,000. So it works. So now we know of our costs, when we break them down, there's a piece that's fixed, which we can figure out. And then there's a piece that's variable, which we can figure out. That's important. Why? Contribution margin statement. Every dollar in revenue, we're going to chew up some in variable cost, and we're going to chew up some in fixed cost. And if there's anything left, it's going to be profit. It's the difference between sales and variable costs or contribution margin. So conceptually, if I sell something for $10 and I've got $6 in variable costs, my contribution margin is $4. That means I have $4 left to cover fixed costs and profit. So let's look at a contribution margin statement. 1 unit costs us $10. 1 unit we sell for $10. 3,000 units we sell for $30,000. Our variable costs are $6 a unit. If we have 3,000 units, we have $18,000. Our fixed costs are $9,000 irrespective. Doesn't matter. 9,000. So how much we make for each pizza? What's the ratio of how much we spend per pizza versus how much we make? What's left to cover operating expenses? This is our contribution margin statement. What we have is we have our revenue. $10 a pizza, 3,000 pizzas, $30,000 in revenue. Direct materials, cheese, et cetera, $3. Direct labor, $1.50. Delivery fee, 30 cents. Total, $1.20. Oh, I forgot very well, there's $6 worth of variable costs. So it's direct materials, direct labor, variable electricity, and delivery. So if we sell something for $10 and we have $6 in variable costs, we have a $4 contribution margin. The contribution margin ratio is the contribution margin of $4 divided by revenue, which is $10, so it's 40%. So we have 2 ways of looking at contribution margin. It's either a dollar amount or a ratio. Then we have our fixed costs here, which equate to $3, leaving us with $1 operating profit. So what? What do we do with this? Conceptually, what do we do with this? We heard all this from the opening video, but what do we do with this? So our contribution margin ratio is the contribution margin divided by revenue. $4 divided by $10 is 40%. Tells managers how a company's operating profit will change as revenue changes. So how profit changes as revenue changes. Specifically, we expect sales to increase by $2,000. And we have a contribution margin of 40%. What would we expect our operating profit to jump by because of that $2,000 increase in sales? We have a $2,000 increase in sales. We have a 40% contribution margin. So we would expect our operating profit to jump by $800. A couple of the other things you're going to need to know. Variable cost per unit is variable costs over the number of units. Contribution margin per unit, sales per unit minus variable cost per unit. And operating profit is total contribution margin minus fixed costs. Okay. See if anybody's paying attention. No, you're not. I know you're not. Contribution margin is $4.40 a unit. Sales was $8.90 a unit. What's the variable cost per unit? So we have sales. Contribution margin $4.40. That's so once you have the equation in place, it doesn't matter what you're missing, you just plug it in. So what do we have? We have $8.90 is our sales price and $4.40 is our contribution margin. So $8.90 minus $4.40 is $4.50. $4.50 is our variable cost. If you have one, if you're missing one and you have the other two, you can figure out what it is. If the contribution margin ratio is 30% and the total revenue is $100,000, what's the contribution margin in dollars? Really, but yeah, that's the answer. If the sales price is $5.50 a unit, the contribution margin is $2.30 a unit, and there's 10,000 units sold, what are the total variable costs? So we go to what's the variable cost per unit? Our sales price is $5.50 and our contribution margin is $2.30. What's our variable cost per unit? $2.20, right? $3.20. How many units are there? So 32,000. That's as hard as the math gets. I promise that's as hard as the math gets. The cost that does not change as production volume changes is known as a so now we know how to figure out what our revenue is, what our contribution margin is. From those, we can tell what our fixed costs are. I'm sorry, we can tell, and if we ever fixed costs, we know what our profit is. What is break even? Definition of break even, yes, thank you, is we don't have a profit and we don't have a loss. It's zero. It's better than minus, but it's not a great way to run a company. So what we need to know is what is break even? How do we figure it out? Because if we're looking for break, if we're looking to decide we have a company, we want it to be profitable, we need to know when it stops being profitable. Or if we're losing money, when it stops losing money, when it breaks even. That's an important point for us in business. So we're going to find different ways to look at it. We're under the graphical method and the equation method. The graphical method, we look at profit volume graph and cost volume profit graph. And then we're going to go to the equation method. The graphical method is great from a presentation perspective because you can put a graph on the wall and somebody looks at it and goes, I get it. I see where that number, where the lines cross, I understand. The problem is you kind of have to interpolate where that number is. And you have to back away from it. It's not very accurate. But it's great to give you a quick example. So we'll look at our first two graphs. The profit volume graph. Profit volume graph is very straightforward. That's what I said. These are great for demonstration purposes because you can look at it and say, I get it. When it stops being red and starts being green, that's break even. Specifically, in our case, it's 2,500 units. What it says is that we have some fixed costs, and the fixed costs have to be $10,000, because if we produce nothing, we're losing $10,000. If we sell 5,000 pizzas, we're making $10,000. Conceptually, it's not that hard to figure out at that point where the break even is, but play the game for the time being. What's the horizontal axis? The number of units produced and sold. We're assuming we're not stockpiling pizzas. If we make one, we sell. And then operating profit here, which is revenue minus contribution margin minus fixed costs. So we know where the break-even margin is here, but we can also look at other points on the chart and say, what happened? Where do we make $5,000? How many pizzas do we have to sell to make $5,000? Now we can look at this graph and go, yeah, it's kind of like around here somewhere. It's like 3,800 units or something. So you can see that at $5,000 profit, we're going to have to sell around 3,800 pizzas, but it's not very good for telling you exactly how many pizzas. So it's good for loosey-goosey stuff, but not great for exact numbers. Cost volume profit graph is the second way to look at it. What it says is, let's separate out our costs. We'll separate out into fixed costs, which is $10,000. And then we have our variable costs, which climb for each additional pizza. How does that look against our revenue graph? Well, our revenue graph is going to be linear, and it's going to be a 45-degree graph. It's going to be steeper than our variable cost graph. But apart from that, it's not as useful as it could be. Because you can look at that and go, yeah, okay, conceptually I get it, but I can't tell you exactly what it means on a number by number basis. So we say thank you. We've done our graphical method. I'm not going to ask you to do it. It's painful. For you to take, it is painful, and it involves graph paper, and you feel like you're in 12th grade and you like drawing stuff with crayons and stuff. I don't do that. So we're going to ignore the graphical method, understand it, but we're not going to use it. We're going to use the equation. And the equation method is this. What is operating profit? Think of it logically. Operating profit is what we sell. So how many at what price, minus our variable costs, which are the variable costs times how many, minus fixed costs. That's our operating profit. Whatever's left over is our operating profit. We can play around with this a little bit. See, let's take the quantities out, because the quantities are the same for both, right? So if we have price minus variable costs times quantities minus fixed is equal. So this is kind of useful because this is our contribution margin ratio. Price minus variable costs, contribution margin ratio, times quantity minus fixed costs equal profit. Now, as long as we know three of these things, we can calculate the fourth. And it doesn't matter which three we know. For example, number of units. So settling for Q, number of units, is fixed costs plus fixed costs plus operating income divided by contribution margins per unit. So what we're going to end up doing if we're solving for Q is fixed costs go over here, so it's profits minus fixed costs. And then we have to divide both sides by this, get rid of it. So it's going to be profit minus fixed costs over that. So that's number of units. And how do we use that? What's it for? Why do I care what number of units it is? We have a contribution margin of $4 per unit. Remember, we're selling for $10. We have $6 of variable cost. So we have a $4 contribution. And we have fixed costs that are $10,000. How many pizzas do we have to make to break even to generate that $10,000? Well, we have $10,000 divided by $4 a pizza. So we have to generate 2,500 pizzas. This is a very important formula. Break-even point in units, it's fixed costs plus your anticipated profit divided by your contribution margin per unit. If you're trying to break even, your anticipated profit is bupkis, 0. So it's just fixed costs. So we break even, it's 2,500 pizzas. What happens if we want to generate a profit of $20,000? Now it becomes useful. See, I want to generate $20,000. So now I have to cover my fixed costs plus $20,000 in order to get to that place. We use exactly the same formula. Fixed cost plus $20,000 divided by contribution margin per unit. That'll tell you how many units you have to generate your $20,000. So we have to cover our $10,000 plus our $20,000 profit. We have $4 in unit, $4 to do it with. So we have $30,000 we have to cover using 4,000 units. 7,500 units, we have to sell 7,500 pizzas to generate $20,000. Too fast? No, we're good? Okay. Doesn't matter if we do it using the graphical method or not. It's gonna give the same answer, but I'm not gonna show it. Once we have this, we can answer any of the questions we need to ask. So, how much revenue do we need to have in order to generate our $20,000 profit? So we have to cover fixed costs plus a required profit, so $30,000. What's our contribution margin ratio? 40%. $30,000 divided by 40%. $75,000 revenue will give us our $20,000 profit. So either we have to sell 7,500 units or $75,000. Quick question, how much are we selling pizzas for? $10. So we either sell 7,500 pizzas or 7,500 pizzas at $10 to make $75,000. That's how they all tie together. So we can use the formula to either give us money or numbers, but if we know the selling price, it doesn't matter because we can just calculate one and divide it, right? So assume we have a contribution margin of $10 per unit and fixed costs of $50,000. Selling price of each unit is $25. How many units do we need to break even? So what's our fixed cost? Plus how much to break even? 0, right? So 50,000 divided by, what's the contribution margin? 50,000 divided by 10 is equal to 5,000. Yeah. That's the class. That's it. I can do magic or something if you want me to. Do you want to take a break and then we'll come back and do some questions? Or do you want to just do the questions? I don't care, whichever. We're here till the duration anyway. If you want to go, we can just go, or if you want to go, we can just go. It's only 4 of you, you can both. Yeah. Okay, we'll have a break. 10-minute break. Okay, well, everybody's here, so we might as well start. You guys want to keep going?
No, we're good.
I'm fine, I don't care.
We're good.
Okay. So, whenever I get these kinds of questions, I know I'm gonna have to refer back to them. So I like spreadsheets because they just make it easier. So I just transpose the whole question over onto a spreadsheet over here. So what we have is we have our production and we have our amounts. Using the high-low method, what are the fixed costs and the variable costs? So what we have to do is, what's the high level of production? May, 480,7,600. The low level of production is April, H. 8,000, 290,000. So we say, thank you, those are good numbers. What's the difference between the two? We have $400,000 and 4,700 units. Or we have $400,000 that have to be generated by 4,700 units, or it's 1.175 pennies per unit. Doesn't seem like a lot. Seems like a pretty crappy business, actually, whatever. So that's our variable cost per unit, 1.175. So what's the fixed portion of costs? Well, we pick one of them. In May, we have $4,800 that are generated by 7,600 units. Okay. So we know that $7,600 is the total cost. What's our variable cost? Variable cost is 1.175 pennies per unit times 480,000 or $5,640. The fixed cost has to be the difference between the two. $1,960. Has to. So that means when you flip the lights on, it's $1,960, and then for everything you do after that, it's 1.175 pennies per unit. Okay, third question is fine. Now assume we have 420,000 novels remaining. What's our variable and fixed costs? Well, we know what our fixed costs are because we just calculated it was 1,960. If we're doing 420,000 novels, we know what our variable cost per novel is. It's 1.175 pennies. So 1.175 pennies times 420,000 is going to give us our variable cost. So our total cost is a combination of 1,960 plus that. Yeah. Okay. Frog company manufactures ceramic frogs. So what you would not think to be a great business. Each frog sells for $25 and has variable manufacturing costs of $11. There's total fixed costs of $2.3 million. So once again, what do we know? Price is $25, variable cost $11, and fixed costs are $2.3 million. We know what our price and our variable costs are. We know that our contribution margin is the difference between the two. It's $14. If it's $14, then contribution margin ratio is 14 divided by 25, which is 56%. Now the questions. We want to earn $350,000. How many frogs do we have to sell? Okay. What do we have to cover? We have to cover a fixed cost of $2.3 million. We have to cover $300,000 in profit. And we have a contribution margin of $14 per unit to do it. So we've got 2.65 million, which is 2.3 million plus 300,000, divided by $14 per unit. It's going to take us 189,286 frogs to make our 300,000, 50,000. So do you have this equation? All of that falls in place. It's just a matter of plugging things in. Need to plug that in?
Yeah.
Up here or over there, I guess. Sure. All right, we deliver flyers to homes. Another great business. We paid 5 cents a flyer. We have to pay our delivery guy 3 cents a flyer. There's no other variable costs. Fixed costs are $125,000 a year. Let's assume the fixed costs are my salary, right? So if I want to earn a profit of $75,000, how many flyers do we have to deliver? Okay, what do we know? Fixed costs plus profit divided by contribution margin per unit. Fixed costs are 125,000. Profit we want 75,000. Contribution per unit is our sales minus our variable costs. So 5 minus 3. So it's 2 cents a unit. So we have to make $200,000 at 2 cents a unit. We have to deliver 10 million flyers. I delivered flyers as a child. It's a crappy job. 10 million flyers, a lot of flyers, a lot of them went into the ditch, I gotta tell you. They may not have been delivered as much as they could have been. So that's the answer to that question. Dumbledore Corporation. I didn't write these questions, I promise, but I have read everything. Forecast next year is gonna sell 25,000 units of toaster ovens for $1 million a year. The expected contribution margin ratio is 45%, fixed costs of $375,000. What's the selling price per unit? Well, we're gonna sell $1 million worth at 25,000 units, so it's $1 million divided by 25,000. So what do we know? We know we have 25,000 units. We know we have revenue of $1 million. Contribution margin is 45%. Fixed costs are 375,000. Write them down so you don't get confused. Selling price per unit is units, 25,000. Revenue of $1 million, so it's $40 a unit. 1,000. Contribution margin if 25,000 units are produced. Got a contribution margin ratio of 45%. If we're doing revenue of $1 million, and the contribution margin is 45%, $1,000 is a contribution. Now my brain broke down. I kind of went everywhere. If we want to make $100,000, we have fixed costs of 375,000. We want to make 100,000. We have a margin ratio of 45%. Wow. Let me get our keyboards again. So we have fixed costs plus operating income. So we have 475,000 divided by 45% is going to give us sales required units of 105. $1,055,555.56. Round that to the nearest whole number because you can't make half a toaster. Well, you probably couldn't make half a toaster because you buy half a toaster. Okay. What's the break-even number of units you have to produce? We have fixed costs of 375,000. Our sales price is $40 a unit. Our contribution margin is $18 a unit. 18 is 45% of 40. So we have a fixed cost of 375,000. We have $18 per unit as our margin. 375,000 divided by 18 is going to be 20,833 units we need to make to break even. Questions? I've got more questions, but they're all the same. My recommendation is go through them. Don't shortchange yourself, work through them. I've given you all the answers here on a spreadsheet. I give you all the answers in the PowerPoint as well. However works for you, work through them. The midterm is next week. It's 19 questions. It's a combination of true, false, multiple choice and working through like this. There's pools of questions, so it's randomized and each question has 5 different questions it can deal from. So no 2 people are going to get the same test. It's supposed to be on Monday, but that's Thanksgiving, so I'm not going to do that. Instead, I'm going to open it midnight Monday morning and close it midnight Wednesday. So you've got 3 days to do it because of the long weekend. Okay? So I open it Monday morning at midnight, close it Wednesday night at midnight. So you've got three full days to do it. I'd kind of prefer you did it by yourself, but I really can't control that. Academic honesty applies, blah, 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 right? It is chapters 1 through 5. I would expect it to be more heavily weighted towards 5 and less heavily weighted towards 1. Any questions? If I can find a practice test, I'll send it to you. Yeah, no, you don't want a practice test? I can,
Essay type questions.
this is as close as you're gonna get to an essay type question. So it's not really writing things out, it's just
Do you
answer.
need to complete the spreadsheet or just one?
I'm
answer?
just gonna ask you for the answer and however you want to give me the answer. I find it easier by spreadsheet, but that's just me because I've used spreadsheets all my life. If you're more comfortable using a calculator, just do it. I don't care. Okay. Thank you very much. Have a good day. Oh, by the way, happy Thanksgiving.
Thank you.
Is anybody doing anything? No? Slaughtering a bird or anything? Enjoy anyway, whatever you do, enjoy. Online, any questions?